All right, let's dive right into this explainer. We're going to demystify the fascinating and honestly often chaotic-seeming journey of bringing a product to market. I mean, have you ever looked at a really complex piece of tech or just a perfectly designed everyday object and wondered, how do they even know where to start? Well, today, we're breaking down the exact science and methodology behind that process. We'll explore how abstract ideas get forged into physical realities, and, maybe even more interestingly, how existing physical realities are deconstructed right back into abstract ideas.
Here's our roadmap for today. We're basically going to explore the two-way street of innovation. So we'll start with how products are built from absolute scratch, and then we'll flip it, ending with how we tear them down to actually learn from them.
All right, jumping into our first major concept, the ecosystem versus the capsule. We really need to understand the boundaries of creation here.
So think about product designers. They are literally the frontline troops managing unknown risks at the true ground zero of innovation. Designing a new product, that is the ultimate competitive battleground. It's so much more than just, engineering mechanical specs. It requires effective judgment over technology, you have to anticipate market trends, and your timing has to be absolutely perfect. And yeah, innovation carries massive inherent risks. Things can fail, they can cause harm, or just completely miss the mark with consumers. But managing those unknowns, that's what opens up incredible opportunities for entirely new assemblies and processes.
Now, we really have to draw a sharp line between product design, which is this highly focused, strictly technical capsule, and product development, which is the sweeping, market-responsive business ecosystem that surrounds it. Think of product design as almost a blind search. It requires intuitive insight and incredibly strict execution to take a vision and turn it into technical specs. But product development, that's the entire shebang. It's all the activities from the very second a concept is born. We're talking brand development, marketing, business operations, basically everything that ensures that little technical capsule actually survives in the real world.
And within that massive ecosystem, you're always going to hit these foundational trade-offs. It's a classic balancing act. Quality, costs, and time. If you over-index on pure quality, you're absolutely going to have to negotiate on your cost or your time. Conversely, if you strictly demand a low price point, well, you're compromising on quality or turnaround time. Plus, you have to remember that standardized concepts expire. Market trends are constantly evolving, right? So designers have to maintain tremendous flexibility to adapt to that changing landscape, all without breaking this super delicate balance.
Moving right along, let's look at the spectrum of innovation, where we step up through escalating tiers of risk and invention. Because innovation isn't just a single light bulb moment. It's a spectrum. It steps up from simple variant modifications to adaptive synthesis, all the way up to a high-risk original invention. At the lowest tier, variant design, you're basically just making parametric tweaks to something that already exists, like, say, releasing last year's smartphone in a brand new color. Step it up to adaptive design, and you're synthesizing new requirements based on what the market actually wants, like significantly upgrading that phone's camera. And then finally, you reach original design. This is the highest tier of risk. You are tackling completely open-ended problems to create a ground-up invention, a real game changer.
Okay, so how do we actually move an idea forward? Let's navigate the forward path and check out the modern development architecture.
This forward path generally follows three pretty rigorous phases. And here's an interesting tidbit. A product is actually never killed after phase 3. It simply graduates into physical prototyping and rollout. So, in phase 1, you're understanding the opportunity. You select the product, analyze customer needs, and run a market opportunity analysis. Then, phase 2 is all about developing the concept. So, functional modeling, product architecture, sizing up the competition. By phase 3, you are implementing the concept. That means embodiment engineering, physical and analytical modeling, and creating robust designs for safe performance. Once you lock in phase 3, production planning kicks in, the prototype gets built, and boom, the product is launched. Now, when you're actually executing that architecture, there's a really stark contrast between two main models. You've got the stage gate model, which is this rigid, linear, waterfall kind of approach. Each gate is a strict evaluation point to ensure rigorous checkpointing before anybody deploys a single extra dollar of capital. But on the flip side, you have the spiral model. This one loops continuously through planning, designing, building, and testing. It allows for parallel development and constantly releases workable versions. It is incredibly effective for industries with heavily compressed timelines, like software, where consumer tastes and requirements just shift at lightning speed. But hey, what if you don't actually want to start from scratch? What if the best way forward is actually going backward? That brings us to a really fascinating pivot in this explainer. How do we execute functions when the answers are literally hidden inside a competitor's product? Think about it. If the forward path is about turning ideas into objects, the backward path is about turning objects right back into ideas.
Which leads us nicely to deconstructing the black box, the incredibly valuable methodology of reverse engineering. Now, reverse engineering has one very strict prerequisite. A product must already exist so you can dissect its black box, predict what it's supposed to do, and critically recognize its shortcomings. And I want to be clear here, the goal isn't just to copy. No way. The objective is to understand exactly how competitive products execute their functions. The true value is all about learning, experimenting, and easily visualizing possible alternatives. It's essentially finding the flaws in an existing masterpiece so you can go and build something even better.
To really master this, we turn to Kolb's cognitive loop, which is a fantastic framework for practical deconstruction. To systematically learn from a teardown, designers rely heavily on David Kolb's model of learning. This breaks down the cognitive loop of deconstruction into 4 highly actionable stages: concrete experience, reflective observation, abstract hypothesis, and active experimentation. Now, this isn't just some dry business model. It's a deeply psychological educational cycle that transforms raw observation into a tangible redesign. So let's walk through exactly what happens at each of these 4 stations.
Stage 1 is concrete experience. This is where you get your hands dirty with physical teardowns and dissections to understand the literal function and form of the device. You're taking the physical product and just ripping it apart. This is the concentrate phase, right? You're studying case studies and experiencing the product exactly as it exists out there in the real world, long before you start making any assumptions.
Then we move into stages 2 and 3, where you transition from that physical dissection into mental synthesis. You're evaluating what went right, what went wrong, and building theoretical design blueprints. In reflective observation, you're journaling, discussing, and really zeroing in on the shortcomings you found during that teardown. From there, you shift into abstract hypothesis. This is where the conceptual magic happens. You build design models, you run your analyses, and you construct the underlying theory of exactly how you're going to improve upon that product's original architecture.
And finally, you hit active experimentation. This is where you take all of that backward engineered knowledge and execute your own parametric or adaptive redesign. You're back in the lab running simulations and testing out those new theories. You might decide to just tweak the existing topology, or you might completely replace the functional layout, like swapping a square component for a spherical one just because it improves efficiency. You are actively testing your brand new redesign against the real world.
Okay. Let's tie these 2 completely different paths together into one cohesive ecosystem with the unified evolution model.
What's really incredible here is how perfectly the forward creation path mirrors the backward redesign path. It basically proves that deconstruction is just another form of creation. Think about it. Understanding the opportunity aligns perfectly with reverse engineering. Developing a concept directly mirrors developing a redesign. And implementing the concept is the exact same procedural step as implementing a redesign. Whether you're starting from a blank whiteboard or you've got a competitor's torn-apart motor sitting on your desk, the cognitive and structural steps to bring that new product to market are totally unified.
Now, the science of product design is incredibly rich with tradition, but as this quote beautifully reminds us, the ink on the historical manuscript is still wet. Many more chapters are yet to be written, contemplated, and analyzed. The field is constantly evolving. It is wide open for new ideas. The methodologies we've walked through today, from those rigid stage gate checks all the way to Kolb's learning cycle, they're the foundations, absolutely. But they aren't the final word. Every single day, product designers are discovering new ways to synthesize concepts, balance those tricky trade-offs of quality, time, and cost, and just generally push the boundaries of what's possible at the ground zero of innovation.
So as you process everything we've unpacked in this explainer, I want to leave you with this final thought. How will you balance the forward and backward paths to create something entirely new? Will you invent from scratch, taking on that highest tier of risk? Or will you find the ultimate inspiration hidden inside a pre-existing black box? The tools, the frameworks, they're all right there waiting for you. So what chapter will you write in the ongoing evolution of product design?